It's amazing the amount of difference that this makes already. Welcome to another video. My name is Roman and today I'm going to build acoustic panels. I want to fix the biggest issue that's currently in this room where I record my videos. And as you can probably tell, especially if I remove all the effects that make the audio sound better, there is a lot of echo and reverb going on in this room. Let's create a little bass line. Test. And we'll use that audio fragment as a baseline for our project to make a comparison. In the end, we'll see if we made some progress or fix the issue. I can even hear my own voice just bouncing around while I'm talking now. But before we fix that, there's another thing that is bothering me in this room, and I have a little side quest that I want to do first. You might not know this, but if we zoom out a little bit, it's quite a mess. This is a room above our garage. It's also the main storage and dumping area for stuff that doesn't really have a place yet, or still has to be sorted out. So I'm ducking underneath the lights to get behind this desk, and I would really like a small area to store some camera gear, tools, and items off camera. I've been placing everything on the ground or on top of random storage crates and shelves, and that's less than ideal. And because I already moved one desk in here, let's do another one. Now, let's get this side quest out of the way. That way I'll have a nice working area to build the acoustic panels as well. So before being able to place the table, I have to create a little bit of space. So I just move all the stuff around to make enough space for the table, and then I just stuff everything back underneath the table. And that's basically how I created enough space to at least have a flat surface on which I can store a few things. And this also made it possible that I could move the table a bit more to the center of the room and have a little bit more space to walk around. And with that, our side quest is already completed. So I have a little bit more space and a little bit more room to work with. I can even walk around the table freely now, and I don't even have to duck underneath the lights anymore to get there. So let's get started on our acoustic panels. And these panels will be mounted on the ceiling. It's a vaulted ceiling, or I don't know, it's this point shape, typical Dutch housing. First I'll hop into Blender to sort of visualize my initial idea. I'll start off with a rough shape of the pointy roof. Keep in mind that I haven't measured or done anything yet. I'm just estimating the dimensions and visualizing the idea. We'll get to the specific measurements later. The main idea is to have about 6 acoustic panels, 3 on each side, which are sort of floating in between the beams. And by making them floating instead of mounted flat to the ceiling panels, I hope to increase the efficiency by creating another trap for the sound to get captured. I want to have them on the top part of the ceiling, so they are out of the way. It's up above headroom and they don't minimize storage in the room. And I'm going to mount them to the beams with some 3D printed brackets. So that's a rough idea for this build project. Now only the hard work is left where I actually have to go do stuff. So let's make a little list and see what we need for this project. First I have to find some usable wood. Then I have to prepare the wood. Oh wow, that sounds awful. Timber, planks, maybe logs. I'll stay with wood, just don't think weird about it, okay? Then we have to create the acoustic panels, measure everything from mounting, securing the panels, 3D design and print some brackets, and finally secure the brackets and acoustic panels to the ceiling. If all that is done, we can compare the before and after to see if I was able to fix my echo problem here. So that's quite a list to go through. So let's start straight away with looking for some nice wood. I start off looking in the garage at this random pile of wood that's being kept there because it's quite nice and fresh, and opposed to the other wood that's stored in the garden shed. So let me know if that's something common with you as well. Let me know in the comments down below if it's normal to have separate piles of wood laying around, each with its own purpose. But not being able to find what I was looking for in the garage, I went to the garden shed to check the other pile of wood. And I still had some pallets there that had sort of workable dimensions for the acoustic panels that I was looking for. So most of the pallet wood was like 9 centimeters wide, which is ideal for the 2 layers of insulation of 4.5 centimeters each that I'm going to be placing in these panels. Now that I found the proper wood, I can take it all outside to get it ready for disassembling. Because these are pallets, there are large variations of usable planks and different lengths, and I really have to look for what I need for this project. I start off by measuring and just looking for the boards that have the right size. I know the insulation panels that I'm going to be using will be 120 centimeters by 60 centimeters. And luckily for me, on these smaller pallets, I found some wood with the perfect length of 60 centimeters. So I start tearing these apart first. Now all of these pallets are built different, so some pallets have just one nail keeping plank to the footer or the bottom side, but other pallets have like 3 nails that are curled on the one side to really keep the wood in place. So I'm just trying to extract everything carefully without damaging or splitting the panels that I'm looking for, which was quite the task to do that properly. Now going through all these pallets really took a long time. I spent a couple of hours working on this, and working with this much wood really took a toll on my arms and legs as well. But fortunately for me, there were 2 main pallets that nearly had all the wood that I was looking for. Now the downside to this was that these were the largest pallets that were there, and they were the heaviest as well. And they had the most difficult nails that I ever found in any pallet before. They were stapled through both boards, and then they were curled around on the bottom side, as you can see on screen now. And it really took a lot of effort to try to safely extract the boards that I needed. And some were inevitably damaged, just split in the center, or were damaged by the transport already. So I couldn't use every board, but I was able to save like 90 to 95% of them. So yeah, that was a lot of work, but in the end I still think it was worth it. I could have bought new wood to start this whole project with, but I really wanted to be cautious about reusing materials, and instead of throwing these away or burning them, I can just repurpose them. So that's, for me, all worth the effort of doing this instead of just buying a new pack of wood at a local hardware store. And while disassembling all these pallets, I also found some sort of a flow to work with. I I just started out with removing the outer boards, and then you can fairly easily, by twisting all the planks, just remove the center boards as well. Things just loosen up and break, and you can basically pry it apart without damaging too much. Now, next to just tearing everything apart, a lot of time went into removing nails from every single board. So that was a good couple of hours as well. And after all that work, I still have a few good pellets left, and I have a few scraps that I can burn in my fire pit, a bunch of nails, and a nice pile of wood that we can use for this project. And the next step is going to be preparing the wood. So for this, there are two main things that I'm going to do. Is we have to cut everything to size, and then I'm going to sand it so you don't get splinters and it won't ruin the cotton or work on the insulation. So for that, I took one insulation sheet as sort of a reference for the size of the planks that we have to cut. And of course, the day that we are doing this is the hottest day so far. So it's about 30 degrees outside Celsius, and in the Netherlands, that's like scorching hot. But we have to continue this project, so I will sacrifice myself for your entertainment, of course. So feel free to like and subscribe if you're enjoying this video so far. I started off by just separating the boards in sort of 6 groups, one for each panel, as the boards had just slightly different dimensions to them. Some boards were 1.20 meters, some were 1.24 meters. The width was all the same, but lengthwise there were 2 main differences at that. And I screwed up one of those, but we'll get to that later. And because of these 2 dimensions, I had the idea to make sort of 2 different groups. One group of 1.20 meters and one group of 1.24. What this allowed me to do is play a little bit with the board orientation, because if we add 2 planks to those 24 centimeters, we get enough overlap to fix that gap or cross that. Because for the smaller boards, as mentioned before in the disassembly step, we had some pallets that were exactly 60 centimeters. So those would be ideal for the inside of the frame. As to, the outside boards have to be a bit longer in that case. So those compensate each other great. It just increases the risk of something going wrong by a little. So I finish up measuring and just organizing everything into 6 groups, one for each panel, with a few boards to spare, which come in handy later, but I'll leave it at that for now. I did the final reference to the insulation panel to see if the dimensions were correct, and everything seemed to line up nicely. So that's nice to know as well. Because I don't have any build dimensions, I don't have any templates, I don't have any exact measurements. I just do this by how the materials fit together. Where my main reference is the insulation panel of 1.20 meters long by 60 wide. And I don't know if it's by luck or just they are more normalized sizes, but this pallet would seem to be perfect for this project and fit to those dimensions as well. I ended up only having to cut down like 5 or 6 boards by maybe 10 to 15 centimeters. And that was it for this whole project for all the 6 panels. And of course the last step, never skip this, always sand your wood. Yeah, for me this is also to remove the imperfections and grime that has accumulated on these boards from being pallets that have been dragged around and stored and so on. And also to just avoid myself from getting splinters or the cotton that I'm going to wrap around it or the insulation that I'm going to work with to get stuck to the sides of these boards as well. It's just nicer to work with some cleaned up wood. And this step took, for the preparation of the wood, definitely took the longest of measuring and cutting down. That was quite easy, but sanding every board and every side took a couple of hours as well. And I really had to put something down to protect me from the sun, because it was burning all this time. And I think for all these steps, the measuring, the cutting, the sanding, I spent about 4 to 5 hours just doing everything one after the other. There weren't really any breaks, and just trying to get this done as quickly as possible so I could get out of the heat. Finally, I just numbered everything so I could get the groups right when dragging everything upstairs again and not lose track of what goes with what. And with that, we have another step done. Our wood is prepared and we can continue with building the acoustic panels. And now that we have our pallet in nice proper sizes and dimensions, we can start the assembly process, for which I have a few additional materials here. This is the insulation that I'll be using. There's a whole pack that I ordered. It came with 13 sheets for a single pack, something about 120 euros, I think. The very nice part about this insulation is that it's made completely out of cotton and reclaimed or repurposed clothing. So it's safe to breathe, it's not rock wool, it's not mineral insulation stuff that's very, very bad for your lungs. So definitely wear a respirator or something, protect yourself if you're working with that. I'll be using this stuff. And it should be very good for audio or sound insulation as well for our acoustic panels. And I have some basic Amazon cotton to just seal the box on the outside. Makes it look a little bit nicer than the plain wood, and some insulation. So I've got all the number 1 planks here. They're all numbered in the center. And I'm going to check which direction that this box has to go together. I'll show it here in the center. Between them lining up like this, or if the board will come to the side. So that's the only thing that I really have to look out for. But other than that, everything should line up nicely. And I'm going to mount everything together with some steel nails. Now there are 2 reasons why I'm using steel nails for this project. One is these acoustic panels are going up on the ceiling and they are not moving. There's also cloth coming around it, so there's no way they're going to be pulled apart or something like that. So these nails will just suffice strength-wise. The other one is to
minimize the risk of the planks on which I'm going into the grain of them splitting up. I only have so much pallet wood that's just enough for this project, so I don't want to risk that as well. Where with torquing down screws, I have the feeling that this might rip the planks apart.
So for the cloth, I got some Amazon cotton cloth, I don't know, woven something. It's not that thick, and there are two packages because the maximum size was 5 meters by 1.60 meters. So I got one of those and the same one, just 1 meter by 1.60 meters. Because the panel is 1.20 meters and we need something to wrap around the edges, and to the sides it's like 60 and then wrap around the edges. Because it's reclaimed pallet wood, it won't be perfect, and I don't have a planer and sander and all that stuff, so I don't work with those. But for me, for the outside, I just want the cleanest edge. So this one seems quite sharp on all sides. We only have this indentation here, but I don't think it really matters for this one. They all look quite nice. So yeah, we'll just go with this one as the outside. So I'm going to lay down the cloth, lay this one on top of it, and then we're going to staple all the cloth to it.
Now the first thing that I'm trying to figure out is where to start, because I want to keep the tension on the cotton as consistent as possible to avoid any wrinkles in the cloth in the end. So I don't want any wrinkles or streaks that will be visible when it's on the ceiling. So I decided to start on the short side first, and then I'll do the short side on the opposite side so I can make sure that I have the proper tension on the cloth, and I can also make sure that the frame stays square, because that's also important. If you nail it down crooked, it will remain crooked. After I've done that, it's very important to neatly work away the corners as well. So I found a little solution to that. It was a little bit of finessing and figuring out what would look nice, but I decided to fold the excess material towards the inside and then staple it together on top of the corner. So we get a nice streak along the sharp edge of the frame that hides the seam. And then for tacking everything down, I try to stay as consistent as possible. It was about 10 centimeters, which is I think 4 inches or something, between each staple. And on the long side, I cut away the excess of cotton cloth. And with the frame completed, I can now fill it with the insulation. Now everything was going well so far, but this very first frame is also the one where I messed up. In the video I don't know this yet, of course, but this very first frame consists of 2 long planks of 124 centimeters and 2 long short planks, if that makes sense, and that are 64 centimeters instead of 60. So it has some additional width to the frame, which makes the acoustic insulation that's being fitted fit very loosely in this frame. And I only noticed that when I started working on the second frame, which fit correctly. But yeah, unfortunately I got my wood mixed up in this acoustic panel.
So I had this little cut off. This is from the tall side, from the 1.60 meters. So I cut this one off, and I think this will be a nice band to keep the insulation in place even better. So I'm going to staple this on as well as just a backplate reinforcement to keep everything in place. Not that I think that something will happen, but it's just a little something to increase the stability. Alright, so this is the first panel done. Let's see if we can pick it up. Everything stays in place. So far so good. There's a little bit of, what do you call this? Sag in the bottom here, where I can see that the insulation is being pushed into the cloth. So maybe I have to tension the cloth even just a little bit more. Okay. I'll continue now, and let's just do a montage for this one again. Otherwise it will take quite some time. But I'm going to do this 5 more times now.
Now, all you see is a time lapse, of course, but creating these panels, these are some of the moments that I enjoy most. Even though it takes hours and can be repetitive to some extent, I'm just creating stuff, I'm in the flow, I'm in my zone, and there's a tangible result in the end, which is very rewarding, I think. That's also why I like to just build stuff, regardless of what it is, what the project is. If I can just do things, build things, I'm happy. So let me know if you recognize that feeling or that state. Because I was lacking that for a long time, and now creating these videos and these projects is really bringing that back, and it has done a lot for my mental health as well.
And with all that done, I have now 6 acoustic panels, which are not all the same dimensions. That's due to the pallet wood that we used that wasn't straight. These are acoustic panels, they go up to the ceiling and nobody sees them. They just have a mainly functional purpose, and that's reduce the noise and echo in here, and the reverb. As you can see, this one I think I messed up numbering everything. It's about 2 centimeters wider than all the other panels, so I have to keep that in mind, creating some sort of bracket or system to get them up there, because I haven't thought of that. I hope they fit how I intend to place them, mount them. I haven't measured that yet. I guesstimated that this would be fine. So we'll see if that's accurate or not. So yeah, let's get to measuring.
So for measuring, there's a couple things that we need to do, or that we need to know. So first of all, I'm checking the accuracy on all the panels lengthwise, because there is some variations in these. As mentioned before, the pallet wood, I didn't cut them on the millimeter correct, so there are some variations. And the same for the width. And next up, we can measure the ceiling. I measured the beam width and the distance that the beams are apart as well. And this should give me enough information to work with. And I still don't know if I'm just stubborn or lazy or something else. Let me know if this is relatable, but this is something that I should probably have gotten a ladder for or something to make my life a little bit easier. But I only needed 3 tries to get it up there, and I got what I needed. Now for the other side, first try, we had some practice now, so... And who would have known, it's exactly the same distance. So somebody did something right building this house. But now we know, and we can continue with our measurements. And of course, that's another thing we can cross off our list now. And the next step, of course, is 3D design and 3D printing for the brackets of our acoustic panels. With our new measurements, we can hop back into Blender, and I start off by just tweaking the roof a little bit with the new measurements to make sure that it's more accurate. I'm not going to do this on the millimeter correctly, but just a rough recreation of the roof with the measurements that I took. So I don't care about the distance between the panel and the roof line and those things, just the location of the two beams on which I have to create the holding brackets. And the idea I came up with for the brackets was a 3-point holding system. I want to place each one bracket on the bottom corners, and for the top I will do one in the center, because it's just there to hold it up. For the bottom corners I want a small footprint. I don't want to extrude it too much over the panel, so I went with a small ledge that picks up the panel. And I find it important to place them in the corners so that they also have some leverage on the plank that goes upwards, depending on how they are mounted, because we have the two variations going on with the long plank on the outside or on top of the smaller plank. And when I had a design for the bottom brackets, I basically just flipped the design up and created the top brackets with the same base as well. That way I had the edge or the ledge that catches the panel that would be exactly the same in that way. And I added some holes where I could put screws in, and I added a inset so that there's a ledge that catches the screw head as well, so I can tightly connect them to the beams. I also try to keep in mind a bit of the aesthetics from the outside so that it wouldn't be too apparent. I also placed a flat surface going towards the panel as sort of an extension of the beam that makes it look more integrated as well. But I'm not that worried about the aesthetics. The most important thing is that they hold the panels in place. And then I exported the brackets from Blender as STLs to Bamboo Studio. Now, there's one important way that we have to place these brackets on the print bed, and that's due to the strength that I want for these pieces, and because it's very directional. Because the most important parts for these brackets is the surface on which the acoustic panels will lay down and put the most amount of pressure. So first of all, I switched the infill from 15% normal infill, the lines or the squares, to 10% gyroid infill. And I took it down from 15 to 10% because I think it will still have plenty of strength left, and it uses a lot less filament. Now, if we'll take a look at the orientation, we have a couple of options how we want to place it on a print bed. The first one would be straight, how it's mounted to the beams as well, but this will create a single point of failure if we put pressure on the ledge. It will just have the possibility to shear off the print among the layer lines. Now, if we lay it flat, we get a different situation. We have our ledge, and the ledge will carry all the weight, and the screw holes are a bit above that, so it will also have the possibility to just shear off among the layer lines if we put pressure on our ledge. So now we come to the last option. This for me is the ideal printing orientation for this piece, which is on its side, and this will make sure that if there's pressure applied to the ledge or where our acoustic panel will lay, it will put pressure on every single layer line. So it's a lot less chance that this will fail or break. The only issue that we have now is that there's a floating piece. So I'm going to fix that really quick by just making sure that for our print orientation, I get a more sloped surface. This point that's sticking out, it can be smaller, is just to hold the panel in place, and there are two of them, so they can easily carry that weight, and they're also pushing in the same direction of the screws. And by adjusting that and reslicing, I now have no more errors on my piece, and the slice is okay, and we're ready for printing. So then it's just making sure that our settings are okay, that we have the proper filament. I'm going to print this in all just PLA basic in the white color, so it matches the ceiling and the panels as well. And even though my printer was already begging me to lube its rods after the last project, I asked for it to hang in there for one more push and promise that after this project I'll take care of all of its needs. Now, having added the second printer, it's a real time saver. So after the H2C does its initial startup dance routine, I start up the P1S as well to print the same part, so that we have both of the foot brackets or the lower brackets printing in the same time. They per part need about 4 hours and 15 minutes to print. And these two first parts printed without any issues, so I'm very happy with that. No major defects or imperfections or just a mess because there's lack of support. But everything printed nicely, was very easy to remove from the print bed as well, which is also important. And after these two completed, I started the last print for the center beam bracket thing for the top of the ceiling. And that print took about 5 hours and 15 minutes. So a little bit longer, but it's a bigger part. And luckily that one printed without any issues as well.
I've got the first parts printed. I only printed for one panel to just fit everything and make sure that everything has the correct dimensions. I did bring a ladder this time to not have the same things as with measuring.
So I start off by measuring on the beam where I want the first panel to go, basically dividing the roof in 3 parts. Now, putting these brackets in is all fairly straightforward. It's just 2 holes, you put a screw in and you tighten them. That's it. So we repeat those same steps for this top bracket as well. And then after placing the brackets, the only thing left to do is to place the acoustic panel and see if it fits. Now, those panels aren't that heavy, but you have to be careful to just not fall over or something. But yeah. And as you can probably tell, we might have a slight issue in the top part of our panel. but it somewhat held the panel, so I decided to leave it there anyway. Now the bottom brackets are looking fine. Top bracket, it needs a little bit of work. And there was another thing with the spacing. I could see this visually, but I decided to measure it as well. There's about 1.5 centimeters of a difference between the top and the bottom of our panel and the ceiling. So I want to fix that as well. So I took everything back into Blender and I started tweaking the top bracket. I raised it about 1 centimeter and I extended it about 2 centimeters. So it will have 2 centimeters more overlap on the panel and it will be raised 1 centimeter to close that side gap that we have to make it more even with the rest of the panel in reference to the ceiling. And I tweaked the top part as well to make it a little bit more slimmer and remove the extra holes that were there for additional screws from the sides because we just didn't need them. Then I removed the first bracket and replaced it with the new bracket. Putting the panel in for the first time and now it fits nicely.
First panel's up and I'm pretty sure I messed up the placement. So let's do that again.
I'm pretty sure that I know what went wrong. Let's say that this total length is 3 meters 70 centimeters. I put a placement on 1 meter 23. That's about here and here. And that's where I place the center of the panel. But it should have been in the center of the first part.
So the first panel is up. I'm very happy with how it's looking so far. Both brackets are holding up fine. The second iteration of the top bracket really made a difference. We have a nice consistent gap all along the edge now. And we can continue printing all the other parts.
Now these are just a few, but I needed 10 more bottom brackets and 2 more top brackets. Now I tried this epic YouTube shot where everybody twists their bin with all the 3D printed parts, but I didn't like it. I also might be biased just because it kept going wrong.
Durability test completed, it's fine.
So here's a normal shot.
And with all of these parts here on the table in their final form, we can cross off 3D design and 3D printing from our list as well. Which brings us to the final step, which is placing everything on the ceiling.
Now, because you've seen me mount the first panel, I'm not going to bore you with 5 more of the same installations. So I decided to just time-lapse everything. And the first major obstacle that I encountered was the light fixture that was exactly in the spot where the center bracket had to be. So I decided to remove the bracket again and remove the light, place the light a little bit to the side and place the bracket on the place where the light is. And while doing this, I took an unexpected load to the face in the shape of a screw. In the end, it made about a 2 centimeter difference, I think, because it was still offset on the panel. But it somehow made me feel like I accomplished something, at least. Then everything went well for a little while still recovering from that first experience. Totally unexpected, I took my second load to the face as well in the shape of some wood. It must be a really productive day if it's still morning and you already took 2 loads to the face. But that's the risk of making these YouTube videos, I guess. I'm having to experience all this, even my camera overheated. Or that might be because it's another 30-degree day and we're right underneath the roof with running studio lights and no AC. Let me know in the comments below what you think that might have caused this to happen. And after about 1.5 hours of screwing all the brackets into the beams, we are finally done. All the acoustic panels are now mounted to the ceiling. So I finally put all the camera gear and the table and everything back in place, so we can do our final reveal and really see if these acoustic panels make a difference. But first, let's not forget to check off the final item on our list, which is mounting everything to the ceiling.
So finally, everything is up there. This is my first experience with acoustic panels. I haven't used or created any before this video, but it's amazing the amount of difference that this makes already for me, just hearing the audio in this room and not hearing my voice go around anymore. So this will especially make my life a lot easier, and I can highly recommend a similar project or just store-bought ready-to-go solutions as well. But I hope this improves my videos for all the future content to come that's being filmed here. I'm pretty sure it will, and it will save me a lot of time editing, because echo and reverb is not something that you can really fix. It will only worsen the end result the more there is of it. And a lack of echo and reverb, it means that the audio quality in the end will just be so much better. And I hope that translates into this video as well. So now for our main comparison, let's do the bass line again. Test, test. And we'll compare that to the one from the beginning, so you can hear the difference that I'm hearing at this moment. Test, test. Test, test.
I'm absolutely amazed by these results, so let's listen to them one more time.
Test, test. Test, test. And that will be it for this video. Thank you very much for watching. Like the video if you liked it. Subscribe to the channel if you want to see more of my future projects. The biggest project I'm working on so far, which is also behind me. This one's broken. I have to rip it apart and do it 80% again. But it's coming up. It's almost done. I'm still waiting for a single cable so I can create it properly and then provide it to you guys as well. That's my 3D printed smart LED wall panel. So like the video, subscribe. Thank you very much for watching, and I hope to see you in the next one. Goodbye.